Hi, I'm Jessica, and welcome to our second video in this crash course on finding missing measurements in a solid. So this time we're focusing on volume, which is a secondary 3 topic. We'll be looking at the following concepts in this video. So we're going to be looking at volume formulas for solids. We're also going to be looking at how to isolate a variable, finding missing measurements, and decomposable solids. Before we get started, I just want to review with you the different formulas for the solids that we're going to be dealing with. We're going to be looking at cube, sphere, prism, cylinder, pyramid, and cone. And you'll notice that this is very similar to the slide that I showed you in our previous video when we dealt with area, but the formulas have all changed because this time we're dealing with volume. So I would encourage you, as I have in the past, to keep this on hand. You probably have something very similar in your notes, and it's always good to keep it on hand when you're doing problems involving volume so that you've got a really quick reference right at your fingertips. Finally, before we get going, our problem is going to be involving a half sphere. So if you take a look up the corner here, the sphere, the volume for a sphere is 4 times pi times the radius cubed, all divided by 3. So pay attention in the video to how that is affected when we're dealing with a half sphere. Here we go. So in our first and only example, we have Gabrielle, who wants to buy a new model of microphone. To fit her hand, it has to be less than 23 centimeters high. Will this new microphone fit her hand? So first we got to look at the microphone and how it's composed. It's composed of the following solids. We have a half sphere with a volume of 97.72 centimeters cubed. And that's a pretty important piece of information, so I'm going to write that up here. 97.72 centimeters cubed. All right. Then we've got a truncated cone with a volume of 95 centimeters cubed, and that's right here in green here. So I'm going to also write my 95 centimeters cubed down. We have a cylinder that you see in blue here, whose volume is 132.32 centimeters cubed, and whose radius equals 1/2 of the half sphere's radius. Okay, so I'm going to write down my 132.32 right here. That's the volume of my cylinder, centimeters cubed. But then it gives me information about its radius. And because I've got these two radiuses, I'm going to actually use 2 different R's to denote it. So my half sphere is the bigger radius. So I'm going to write that as big R, so radius of half sphere. And because I'm also talking about radius with my cylinder, but it's a smaller radius, it's actually half of the half sphere's radius. So I'm going to use little r, and that is going to be radius of cylinder, which is, of course, according to the problem, half of the big R. All right, perfect. And finally, we have a cube, which is this gray-white color here, with a volume of 21.95 centimeters cubed. So I'm going to put that in here. 21.95 centimeters cubed. So for the first part of our problem, we're going to find the radius of the half sphere. Before we do, though, I have a question for you. What is the formula to calculate the volume of a half sphere? If you guess B, you're correct. So this is the one we're going to use. And you'll notice that instead of 4 pi r cubed divided by 3, like we saw on the first slide with the formula, we've divided that 4 by 2. So we have 2 pi r cubed divided by 3 for the half sphere. And that is because we literally have half the sphere. So we're going to cut that volume in half. All right. Once I've determined my formula, I replace with the values that I know. So the problem gave me the volume of the half sphere, which is 97.72. That goes in here. And then we still have our 2 pi r cubed divided by 3. And of course, the r cubed isn't going away yet because that's what we're looking for. So we're going to isolate that. To isolate that, we got to get rid of this denominator. So I'm going to do the opposite here. Opposite to dividing by 3, which is to multiply by 3. And then I'm going to multiply by 3 also on the left side here. And in doing so, that gives us 293.16 is equal to 2 pi r cubed. So you see how on this side, our 3's canceled out, and we no longer have a denominator. Now, because this is a multiplication here of 2 pi times the r cubed on the right side, I'm going to have to divide by 2 pi on the right side. And I'm going to throw brackets around that just to make sure that when I type it into my calculator, it actually performs the calculation I want it to perform. Over here, I'm going to do the same thing. I'm going to divide by 2 pi. Perfect. Oh, my pi looks a little strange, so there you go. And when I do that, it gives me 46.66 r cubed. So the 2 pi is no more on this side, and we've got our r cubed. Now, r cubed, we're used to taking the square root, but this time we're going to take the cube root. And so your calculator actually has a function to do that. You're going to use the radical symbol, and then we're taking the cube root here. So it's got to be to the index 3. There you go. So to take the cube root of that, that ends up with 3.6 centimeters. So our radius is approximately 3.6 centimeters. So now instead of writing r, I know that this is going to be 3.6 centimeters. Excellent. So the second part of this problem needs us to find the height of the truncated cone. But wait a minute, we don't have enough time, we don't have enough information yet to do that. Okay, so we're going to have to actually look at doing the cylinder first. So we're going to find the radius of the cylinder before we find anything about the truncated cone. To do that, though, we're going to remember that we already mentioned that the radius of the cylinder is half of the radius of the half sphere. So since we had that earlier in our problem, we're just going to do the calculation here. So I'm going to take the radius of the half sphere and divide that by 2, which is the same as multiplying it by 1/2 to give us 1.8 centimeters. So now we know that the radius of our cylinder here is 1.8 centimeters. So I'm just going to write that in right here because now this is information that we know. All right, now we're ready to find the height of the truncated cone. But before we do, the volume of the truncated cone is always half the volume of the whole cone. Is this true or false? The answer is false. Sometimes it is, but not always. So if we take a look at our cone here, you'll notice that the radius of that half sphere, which is the segment AB up here, that was 3.6. And then we've got the radius of the small cone that we know is 1.8. So that's the segment DE down at the bottom here. And you have over here the height of the entire cone indicated. And then you got the height of this little height right here of this tiny little cone. And that tiny little cone is the cone that we kind of slice off the top. So we can't say right away that the volume of that truncated cone is going to be half that of the entire cone because it really depends at the height at which you sliced the cone. If we look at our example here, though, you might notice that the scale factor that exists between these being similar triangles here that have been created, the scale factor existing between the two radiuses would give us 2 because 3.6 divided by 1.8 is 2. So in this case, in this example, it is going to be half, but it's not always like that. Okay, so to find the height of the truncated cone, we're going to take the volume of the entire cone and we're going to subtract the volume of this little tiny cone that we slice off. So when I replace the numbers that I do know, or the variables that I do know the information for, that's going to give us 95 is equal to pi times 3.6 squared times 2h divided by 3 minus pi times 1.8 squared times h divided by 3. And you'll notice that the h used in the big cone is actually it's that little h there, so it's twice the height of the little cone. And the reason for that is because we determined that in our example, which is not the case for all truncated cones, but in our example, that big height is actually, or the height of the entire cone is actually twice the height of the little cone that we sliced off to create the truncated effect. Okay, so that's why our first part, we're going to find the small height, or the part that we slice off, And then we're going to be using that to find our taller height. Okay. All right. So when we crunch our numbers, this leaves us with 95 is equal to pi times 12.96 times 2h divided by 3 minus pi times 3.24 times h divided by 3, which leaves us with 95 is equal to 8.64 pi h minus 1.08 pi h. And my question for you guys would be, are these like terms? In other words, can we subtract these two numbers? So yes, in fact, these are like terms. We will be able to subtract those two terms here. So when we subtract 8.64 pi times the height and we subtract 1.08 pi h, we end up with 7.56 pi h. So 95 is equal to 7.56 pi h. And of course, we need to isolate this height right here, which is the height of our little cone that we slice off everything. So to do that, we're just going to take 7.56 pi and divide it out on the right, and do the same thing over here on the left. And remember, we need to get these in brackets so that our calculator does the calculation properly. And that leaves us with a height of 4 centimeters. So the height of 4 centimeters is the height of that tiny little cone that we have to slice off. All right, I'm just going to write this down here so we don't lose track of it when I switch the slides, because you're going to see how we use this 4 centimeters right here. So erase that, and we have this big H is equal to 2 times the little h. So in other words, the height of the entire cone is equal to twice the height of the little cone that we slice up. So that leaves us with 2 times 4, which is equal to 8 centimeters. So 8 centimeters, that's the height of the entire thing. It's still not the truncated part. So we're going to put it here to make sure that we don't forget it, because now I'm going to use it to find my truncated height, which is my last step. I'm going to take that big H, so the height of the entire cone, as if it was intact, and I'm going to subtract the height of the little cone that I slice off of it. And that means I'm taking 8, I'm subtracting 4 to leave us with an overall height of 4 centimeters for the truncated portion. So now this is the part that I want to actually retain for the rest of my calculations. So I'm going to say height here truncated is equal to 4 centimeters. Okay, so now we're ready to find the height of the cylinder. So that's the blue portion right here. To do that, we're going to be using this formula. So the volume of the cylinder is equal to the area of the base times the height of the cylinder. Now, the area of a base of a cylinder is, of course, a circle. So we're going to replace, instead of saying AB, we're going to actually use the formula for the area of a circle, which is pi r squared. And then we're going to multiply by height. So we're going to put in the information we know. We did calculate the radius of our cylinder already, and that, because of course it's the smaller side of the truncated cone, so that corresponds to 1.8, which we see replaced in here. So now my problem reads, or my equation reads, 132.32 is equal to pi times 1.8 squared times h. So I do what math I can. I do my calculations here, and I end up with 132.332 is equal to 3.24 pi times h. So of course we still have that h in there. That's the variable we're trying to isolate. And in order to isolate that, we're going to have to divide both sides by 3.24 pi, 3.24 pi. So here we go. 3.24 pi over here. And we're going to divide the left side by 3.24 pi also. And I'm going to again throw my brackets around there, just like that. And we end up with a height of 13 centimeters. So that means that the entire cylinder is 13 centimeters high. We got to cancel these guys out. We're good to go. All right. So you can see that I've already erased my work, but before I go any further, I want to make sure that I take note of the height of the cylinder that we just calculated. So the height of the cylinder is going to be 13 centimeters. There we go. And we're ready to go forward to find the height of the cube. So this is our last solid, and the cube, remember, has all the same dimensions, so which means that our volume formula looks like this. Volume of the cube is simply the side cubed. So we put in the information that we know. We already know from what we were given at the very beginning of the problem that the volume of the cube is 21.95 centimeters cubed, and that's equal to s cubed. So all we have to do is use our calculators to take the cube root. And I got to do the same over here. Perfect. And when I do that, I get a side length of 2.8 centimeters. So that means that the height of my cube is 2.8 centimeters. So I'm going to write that here, and I'm going to use S because that's what I'm using over here anyway. So just to stay consistent, 2.8 centimeters. Perfect. All right. I want to make sure that I'm looking at the total height of my microphone now. So this is the final step. We've got to take all of these heights and add them together. So I'm going to take the height of the half sphere, add that to the truncated cone, to the height of the truncated cone, and add that again to the height of the cylinder, and also to the cube. So when we put in the dimensions that we worked so hard to calculate, that gives us 3.6 plus 4 plus 13 plus 2.8. Of course, we didn't need to do any conversions here because everything was in centimeters to begin with in our calculations. So we're good on that front. We can just simply add up these numbers, and it gives me a grand total of 23.4 centimeters. So that is 23.4 centimeters for the height of this entire microphone. And that 23.4 centimeters is greater than 23 centimeters. So if we go on to just write that complete answer, we have to consider whether or not the height of the microphone fits her hand or does not fit her hand. And since it had to be less than 23 centimeters high to fit her hand, then we know that this does not fit her hand. That's it. All right, so that concludes our second video on finding missing measurements in solids with the area or volume formula. So we can find any missing measurement we need depending on the information that we're given using the formulas that we looked at. If you need a refresher on area, feel free to go back and look at our first video. If you'd like to check your understanding, then go ahead and try some of our exercises.